So today we'll start with the embryology sessions. First session will be a recap of the gametogenesis, right? Some of the things you have already learned in your 12th standard. We'll see what are the process in the gametogenesis, when it starts, and what are the significant features in the gametogenesis. Fine, right. So before starting this gametogenesis, just a recap of mitosis and meiosis, which you have learned in your 12th standard. Fine. What are the stages in mitosis? Prophase, anaphase, in order: prophase, metaphase, anaphase, and telophase. Okay, fine. So prophase, anaphase, prophase, metaphase. Now, this mitosis happens only in the somatic cells, right? So when the cells divide, so there will be an identical daughter cell, and if you see the chromosome complement also, it will be the same as that of the parent cells, right? There will be duplication of DNA material. The DNA gets this one duplicated, and after the division, it will pass on to the daughter cells. So both parent as well as the daughter cell will have the same chromosome complement or the nuclear component. Fine, right? So this happens in all the somatic cells, eukaryotes. Usually, a single cell divides into two identical daughter cells. As you mentioned, so these are the stages. So first it will start with DNA replication or duplication. So then there will be cell divisions. So finally you will end up in two daughter cells. Fine. The stages include prophase, metaphase, anaphase, and then telophase. And the last stage will be the cytokinesis, where there is a division of cytoplasm. Okay, fine. So what happens in prophase, metaphase, anaphase, telophase? All these things you have learned already. The nutshell will be there will be a duplication of DNA material. So the chromosomes will be arranged in an equatorial plane during the metaphase stage, anaphase stage. So these chromosomes get separated out, and then you have the telophase where it gets towards the polar region, and then finally the cytokinesis where you have two daughter cells. Fine. Now, in contrary to this mitosis which is happening in the somatic cells, so there is another cell division called as meiosis. So how many stages in meiosis? So two stages. So we do call it as meiotic 1 and meiotic 2. Fine. Now in case of meiosis, so this division happens only in the germ cells. Here in case of males, so there are cells called as spermatogonia, which gets differentiated into primary spermatocytes, and in case of females, the oogonia, which gets differentiated into primary oocytes. Okay. So it happens only in the division of germ cells. A single germ cell divides into unique daughter cells. Unique daughter cells in the sense the chromosome complement gets reduced to half. So it becomes an haploid number, and it depends. In case of male, a single cell gives rise to 4 spermatids, but in case of females, a single oocyte gets differentiated into or gets divided into one cell actually, and then others will be a polar bodies. So it gives rise to unique daughter cells. And daughter cells have half the number of chromosomes as parent cell. Right? Hence they are called as haploid. So as I mentioned earlier, there are two divisions, meiosis 1 and meiosis 2. In case of meiosis 1, so you have homologous chromosomes coming together, and there will be an exchange of chromosome material. Finally, the chromosome complement gets reduced to half. Right? And meiotic 2 will be almost like a mitotic division, where the two daughter cells, the two cells becomes 4. Fine, right. So, but the outcome of this meiotic divisions will be there will be a haploid daughter cells, haploid daughter cells. So during fertilization, the two gametes will join together to restore the diploid number. Fine, that is after fertilization. Fine. So with this background, so we'll move on to this gametogenesis, right? The nutshell: mitosis happens in the somatic cells. There is no reduction in the chromosome complement. Meiotic divisions happens in the germ cells. There will be a reduction in the chromosome complement. It is called as haploid. Okay. Now, in case of humans, so it all starts with gametogenesis from a cells called as primordial germ cells. Right? So they call it as PGDs. It is called as primordial germ cells. So here in case of humans, so it is refers to formation of gametes. In case of female, it is ova. In case of male, it is a sperm. gametogenesis. These gametes develops from gonads. Within the gonads, we do have some group of cells called as primordial germ cells. We call it as PGC, primordial germ cells. See, up to 8th week of development, the gonads will be in an indifferentiate stage. So it can differentiate into an ovary, or it can differentiate into a testis. So only at the 8th weeks you will have a clear differentiation whether it has developed as an ovary or a testis. So before that stage, it's all called as an indifferent gonad stage. Now, in case of male, the entire process is called as spermatogenesis, and the entire process of spermatogenesis happens in testis, right? And the mature cells which are produced at the end of spermatogenesis are called as sperms. Whereas in case of females, the entire process is called as oogenesis, and it is a formation of ova that happens in the ovary. That is a female gonad, right? So spermatogenesis and oogenesis, these are the gametogenesis process happening in humans, and the gonads will be testis and ovary. Major part of this ones you have done in your 12th standard. We'll start with this one, the primordial germ cells. Okay, now a single cell divides into 2-cell stage, 3-cell stage, 4-cell stage. Likewise, there will be a division, and finally these cells, they get differentiated to form 2 unique layers. Any idea what are those 2 layers called as? Okay, you must be knowing the 3 germ layers. What are the 3 germ layers? Ectoderm, mesoderm, endoderm. So before the formation of these 3 germ layers, the zygote, which divides into 2-cell stage, 4-cell stage, 16-cell stage, gets organized to form 2 layers of cells. These layers of cells are called as trophoblast. Okay, next stage. So before that, it is called as epiblast and hypoblast, right? So that you will see in the next week session, epiblast and hypoblast. Some of the cells of the epiblast, they differentiate into this primordial germ cells. So zygote 1 cell, it becomes 2, 4, 16 cell stage, and they get organized to 2 different layers called as epiblast and hypoblast. And some cells of this epiblast layer gets differentiated to this particular unique cells called as primordial germ cells. Right. Now, this differentiation of 2 layers will be happening in the 2nd week. So 2nd week of development will be unique, so you'll be having 2 layers here in case of epiblast and hypoblast. 2 layers in the outer cell mass, it is like syncytiotrophoblasts and cytotrophoblasts. Likewise, it can be called as week of 2s, right? So during that 2nd week of development, so we have gametes developing from the primordial germ cells. Now, this primordial germ cells should go and then reach which organ? Gonads, right? In case of female, it has to reach ovary. In case of male, it has to reach testes. Fine. Now, the migration starts. So there will be a groove called as primitive streak, and these cells get into the groove and then they get into yolk sac, right? So primordial germ cells, which are derived from the epiblast cells, they get into this yolk sac, they started moving. So during the 4th week, these cells begin to migrate from the yolk sac towards the developing gonad, right? So which cell there is, which week there is a differentiation of primordial germ cells? 2nd week, right? Now from the 2nd week, end of 2nd week, it starts moving towards the yolk sac, right? So 3rd week it will be there in the yolk sac. By the 4th week, it starts moving from the yolk sac to the developing gonad. Right? The developing gonads are the ovary as well as the testis, right? They reach the respective gonads, means they reach the gonads by the end of 5th week. The migration starts after 2nd week. So they reach the final destination by 5th week of development. So by that time, so there will be also differentiation of the gonads, whether it will get differentiated into ovary or whether it will get differentiated into testis. Okay, fine. So the gametes are developed from which group of cells? Primordial germ cells. Primordial germ cells develop from the 2nd week, and they reach the destination by the end of 5th week. Okay, so this is just a picture showing that how it happens. Now, this is much late actually, maybe in the 3rd or 4th, at the end of 3rd week. So now the cells are already in this yolk sac. Right, this is a yolk sac, this is a yolk sac here, and these are already folded embryo. So you can see these cells, these are the primordial germ cells. They are already in the yolk sac. Fine. Now in the next stage, if you see this one, the cells from this yolk sac, they start migrating towards this developing gonad here. See, developing gonad will be here in this region. So this is a mesodermal region called as intermediate mesoderm. Intermediate mesoderm. It's a component of mesoderm which gets differentiated into urogenital organs, right? So whether it is testis or ovary, so both the gonads will develop here. There will be a difference in the development, but whatever it might be, so finally the primordial germ cells will reach this primitive gonad or the developing gonad. Fine, by the end of 5th week. Okay. So this is how the entire process looks like. So it starts from this epiblast, then it reaches the yolk sac, and finally it gets into this gonads, primordial germ cells. So this is a developing gonad, somewhere in the intermediate mesoderm part. It can be ovary or testis, right, where it reaches its final destination. Now, see, during this movement, there will be mitotic divisions of primordial germ cells. So the numbers tend to increase till it reaches the gonad, right? Now these germ cells undergo gametogenesis, which includes meiosis, to reduce the number of chromosomes as well as cytodifferentiation. No need to take all these things, I'll let you know like which are the important things. Okay, fine. So only thing is like during this migration, the cells undergo mitotic divisions. Now, coming to this spermatogenesis. So we target spermatogenesis and move on to oogenesis, and we'll see what are the salient features happening in the spermatogenesis as well as oogenesis. Okay, fine. Now, if you see the process spermatogenesis, what do you mean by spermatogenesis? It is a process by which spermatogonia, the primitive germ cells which has reached the testis, now they are called as spermatogonias. So these spermatogonias differentiate into microspermatozoa, right? The entire process might take around 74 days actually for a complete sperm maturation. That I'll come to that later. Now, the most important thing, the difference between the spermatogenesis and the oogenesis will be spermatogenesis starts or begins at puberty, not before puberty, right? Till puberty, the seminiferous tubules are not canalized and there is no initiation of spermatogenesis. In contrast to oogenesis, which starts before birth, right? Okay. Now, so these spermatozoas are found in the wall of seminiferous tubules of testis. If you take a cross section of a testis, a cross section of the testis, now this testis are made up of different lobes and lobules, and each lobule, if you take, there will be a coils of this seminiferous tubules. So this is a testis, and you can see this is a seminiferous tubules, this is a seminiferous tubule, right? Coils of seminiferous tubule. So these seminiferous tubules are not canalized till puberty. So only during puberty these seminiferous tubules are canalized, and then if you see take a cross section of a seminiferous tubule, so this is a cross section of a seminiferous tubule, you can see the lining epithelium of the seminiferous tubule. It is called as germinal epithelium, right? Why it is called germinal epithelium? Because it gives rise to the germ cells, that is the sperm. Now, the primordial germ cells would have reached this seminiferous tubules, and they are in the walls of the seminiferous tubules, right? Now, during puberty, what happens? At puberty, what happens? these spermatogonial cells, they start differentiating into other cell types. This begins at puberty. Okay, fine. So where the spermatogenesis takes place, it takes place in the testis. Where in testis? Seminiferous tubules in the lumen of the seminiferous tubule. Okay. Now, the first step. Shortly before the puberty, the sex cords of the testis, that is the seminiferous tubules, they acquire a lumen and become the seminiferous tubule. Okay, I don't need to take it off now. At about the same time, the primordial germ cells which are already there in the gonad, they tend to differentiate into spermatogonia. To begin with, it is called as type A spermatogonia, right? Type A spermatogonia. So you can just note it down from the primordial germ cells. It is type A spermatogonia. This type A spermatogonia will also undergo mitotic division, so that it will increase the cell population of type A spermatogonial cells. So this production of type A spermatogonia will mark the initiation of spermatogenesis. So spermatogenesis will start with type A spermatogonia. So just note it down, type A spermatogonia. So as I mentioned earlier, this type A cells will undergo again repeated mitotic divisions to become more and more type A spermatogonial cells. At one stage, the last division of type A spermatogonial cells will give rise to type B spermatogonia. Right? The differentiation, histological differentiation, you will learn later. But as an embryological point of view, the type A spermatogonia differentiates into type B spermatogonial cells, which finally form a group of cells called as primary spermatocytes. Primary spermatocytes. So if you make a flow chart, it will start with primordial germ cells, which gets differentiated into type A spermatogonia. Type A spermatogonia, parallelly it undergoes lot of mitotic division, and finally it gives rise to a group of cells called as type B spermatogonia, and finally to a primary spermatocytes. Right? So this is what happens during puberty. Canalization of seminiferous tubule. The primordial germ cells get differentiated into, that is a spermatogonial cells, which gives rise to type A spermatogonia, and finally the type A spermatogonia will give rise to type B, and finally you have the primary spermatocyte. Now, primary spermatocyte is not equivalent to sperm, so it has to undergo several cell divisions. We'll see that later. Okay, so this flowchart is important. Primordial germ cells to spermatogonial cells, type A, type B, and finally to primary spermatocyte. Now, the meiotic division starts from this level, that is the primary spermatocyte level. So now here happens the reduction in the chromosome number after the primary spermatocytes, which undergoes a meiotic division. So this primary spermatocyte enters into a prolonged prophase, no need to take it down, followed by completion of meiotic 1. So thereby it gives rise to secondary spermatocytes. Right? So primary spermatocytes undergo first meiotic division. This you can just note it down. Cells which undergo the first meiotic divisions will be the primary spermatocytes. Not type A spermatogonia or type B spermatogonia, it is a type A spermatocytes. Okay. So the type A spermatocytes, the primary spermatocytes will undergo this first meiotic division to form secondary spermatocytes. If you see this meiotic division starts with the primary spermatocytes, the 2n chromosome complement will become n, haploid number, and it forms secondary spermatocyte. The secondary spermatocytes undergoes the second meiotic division to form spermatids. So now the spermatids is also like n haploid component. If you see that one parent cell has given rise to 4 spermatids, right? With a reduction in the chromosome complement, this happens in male spermatogenesis. So now we have spermatids. Right. So it all started with primordial germ cells, which gets differentiated into spermatogonial cells type A and type B. Type A has given rise to primary spermatocyte. The meiotic division starts from this primary spermatocyte stage, where the first meiotic division gives rise to secondary spermatocyte, and the second meiotic division, the 4 spermatids. Now, this spermatids undergoes a process called as spermiogenesis. Spermatids looks like a cell. It's a cell, right? They have to differentiate into a mature sperm by a process called as spermiogenesis. Right? By a process called as spermiogenesis to form mature sperms. Fine? Right? Okay. So now we'll see that spermiogenesis process. So to complete this spermatogenesis, so during this process, the entire process, there are another group of cells called as Sertoli cells in the testis, right? So they have 2 functions. One, the supportive function, and also they form a barrier called as blood-testis barrier, right? Because these sperms are newly developing cells, a group of cells or a protein or antigen material. So these sperms will be prevented from the main stream by means of a barrier called as blood-testis barrier. Okay. So just remember, there is another group of cells called as Sertoli cells, which main function will be to form a support for this cell divisions, as well as it forms a barrier called as blood-testis barrier. Blood-testis barrier. Okay. Fine. Now, so this is what happening in this testis now. So testis, if you put seminiferous tubule, so you have one seminiferous tubule that has been enlarged, and you have a germinal epithelium within that seminiferous tubule, and in the germinal epithelium you have a differentiating cells starting from spermatogonia to spermatids, right? So if you see the basal layer, it will be the spermatogonial cells, spermatogonia. Then it gets differentiated into type A, type B is primary spermatocytes, secondary spermatocytes, and finally into mature sperms. Now, as I mentioned earlier, the process by which a spermatid gets differentiated into a mature sperm is called as spermiogenesis. Right? So spermatids to spermatozoa or sperm. Spermatids to spermatozoa or sperm. It is called as spermiogenesis. There are some changes happening in the cell organelles during the stage of spermiogenesis, right? Something are happening. So the cells gets modified to form a motile cell that is called as sperm. The first change includes the formation of acrosome. So above the nucleus, there will be a formation of an acrosomal cap which covers half of the nuclear surface. So this acrosomal cap will have some enzymes which are required for fertilization. Right? Enzymes which are required for fertilization. Number 1, so formation of acrosomal cap. So the changes that is happening during this spermiogenesis. Number 2, the nucleus gets condensed. It is called as condensation of nucleus. If you go and read more about the chromosomal, the nuclear makeup, so the nuclear makeup of the sperm will be different from the normal cells. How they are arranged, all these things like it is different from the normal cells. Now, there is a formation of neck, middle piece and tail. There is a formation of neck, middle piece and tail, and you have a lot of mitochondria getting organized into this middle piece, and finally there is a shedding of most of the cytoplasm. So these are the 4 changes that are happening in the process of spermiogenesis. Number 1, formation of acrosomal cap. Number 2, condensation of nucleus. And formation of neck, middle piece and then tail. And lastly, the shedding of cytoplasm. Okay, so this process is called as spermiogenesis. If you see a picture like how it looks like, this is how spermatid gets differentiated into a mature sperm. So you can see here, this is a nucleus, the initial nucleus. You can see the formation of acrosomal cap. So this is an acrosomal cap here, which will have enzymes necessary for fertilization. And then you have the differentiation of the cell. This is a nucleus acrosomal cap. This is a head region, and this is the mid portion and the tail. So you can have the differentiation of head, neck, middle piece as well as the tail. Okay. So this is the final mature sperm, the fourth one. So now slowly the sperm will attain this motility part. So it becomes more mature, and now it becomes more motile. Okay. Now, so this you have to note it down. So the entire process from spermatogonium to spermatozoon takes place around 74 days. 74 days. During a contraceptive procedure called as no-scalpel vasectomy, sometimes they do vasectomy, and you need to remember the period of spermiogenesis, because during that period there should be an abstinence. So approximately it takes around 74 days, the entire process. Now, there are approximately 300 million sperm cells are produced daily. 300 million sperm cells are produced daily. So just remember, like imagine like how much spermatogonias will be there, how many type A spermatogonia will be there, type B primary spermatocytes, secondary spermatocytes, which give rise to 300 million sperm cells. Okay, now as and when so they start forming that spermatids, they get pushed towards the epididymis, right? So along with the testes, you have a convoluted tubule area, that is the epididymis. So in the epididymis, they get the full motility, right? Not when they are in the testes or in the seminiferous tubule, the full motility as well as the full maturity develops when they pass through this epididymis, right? When they pass through the epididymis. Okay, fine. So to sum up this spermatogenesis, spermatogenesis starts at puberty, right? Please remember, at puberty. The entire process will take around 74 days. The cell which undergoes the first meiotic division will be the primary spermatocytes. First meiotic division, primary spermatocytes, but entirely all the cells will ultimately derive from the primordial germ cells. Fine? Okay. Spermiogenesis means from the spermatids to a mature sperm, the entire process. Spermatogenesis, coming to the next one, that is the oogenesis part. Right. Oogenesis. Oogenesis is slightly more complicated than this spermatogenesis. It is a process by which the oogonia gets differentiated into mature spermatocytes. Okay, fine. Now, once the primordial germ cells, they reach the gonad. When they reach the gonad? 4th week, 5th week. By the end of 5th week, like it will be there in the gonad, right? So at the 5th week itself, it will start differentiating into oogonia. So the entire process of oogenesis starts before birth, right? Spermatogenesis starts only at birth, so at puberty, but oogenesis starts before birth. Now, so this is the main difference, like in case of spermatogenesis as well as oogenesis. Oogenesis starts before birth. Right? So now you have to imagine, so one cell which has started differentiating before birth, it will be viable till around 40 plus years of age. Right? So one cell which has started developing before birth, so it will be viable till 40 plus years of age. Right? Fine. Now, all this oogenesis, the entire process takes place in the ovary. Right? So we saw sperm. We saw testis. The testis is divided into lobes and lobules. Within each lobule we have coils of seminiferous tubule, and within the lumen of seminiferous tubules the spermatogenesis happens. But here in case of ovary, if you take a cross section of an ovary, so we divide the ovary into a cortex part and a medulla part. Cortex and the medulla part. The outer part is the cortex, right? So in the cortex we do have this embedded oogonia, which gets differentiated into various stages, like primary oocyte, secondary oocyte, likewise. So all these stages are seen in the cortex, right? In the medullary region, you will have the blood vessels. So this is what happens in the ovary. So the differentiation takes place in the cortex of the ovary, where you have the cells undergoing different stages of cell divisions, that is the oogenesis. Okay, fine. Now, so if you see that oogenesis, so the primordial germ cells get differentiated into oogonia. So this oogonia, as in case of spermatogonia, they undergo mitosis. So they increase in the number, and some of the cells which gets arrested in meiosis 1, that is in the prophase 1, and form primary oocytes. So they form primary oocytes, like in case of primary spermatocyte, they form primary oocyte. But during this stage of cell division, that is a meiotic 1 cell division, they get arrested in prophase stage, right? So you can just note it down. So the meiosis 1 cell division is not completed. Meiotic 1 cell division is not completed. I'll just come to that later. Okay. Now, by the end of 3rd month, that is 3rd month of intrauterine life. 3rd month of intrauterine life. So these cells, that is the oogonial cells, which is getting differentiated into primary oocytes, they are surrounded by a layer of follicular cells. These follicular cells are derived from this ovary, and they form what is called as primordial follicle. So the oocyte surrounded by a layer of follicular cell is called as a primordial follicle. So all these things are happening before birth. So if you see here, this is called as a primordial follicle. So inside there will be an oocyte, and then surrounded by a layer of follicular cells. So this cell is called as a primordial follicle. Fine. So this happens before birth, almost by the end of like 3rd month to 5th month. All this process is happening in the ovary. Okay. Now, so 3rd month, during the next few months, there will be a rapid increase in the oogonial cells, and by the 5th month of prenatal development, the total number of germ cells in the ovary reaches by around 7 million. Right? So you can just note it down. By around 5th month, you have around 7 million cells. 7 million cells. So this is with respect to this oogonial cells. 7 million. Right? 7 million. Try to compare and then contrast with the spermatogenesis. So in case of spermatogenesis, per day there is a production of around 300 million sperm cells. 300 million sperm cells. But here, the maximum number of oogonial cells are around only 7 million. Right? Now what happens to this 7 million? So one side, so they get differentiated into primary oocytes and gets arrested in prophase 1 of meiosis. And they are also surrounded by a follicular epithelial cells called as primordial follicle. And this 7 million numbers gets reduced subsequently. Okay. So now, so all these things are happening in the ovary. The primary oocytes, so which they have got arrested in the prophase 1 of the first meiotic division. So in the stage called as diploting stage. So if you subdivide the stages, yes. So if you subdivide the stages, it will get arrested in the diploting stage. Now, the primary oocytes which gets arrested in the prophase stage remains arrested till puberty. Right? So before puberty, when they start like ovulating, the first meiotic division gets completed. Right? So the meiotic division started before birth, the primary oocyte. It got arrested into a prolonged prophase of the meiosis 1, and this first meiotic division gets completed only before ovulation. Only before ovulation. Okay, so this is the main thing which you have to understand in case of oogenesis. Okay. Now, so it was originally how much? 7 billion oogonial cells. Now, what happens is to primary oocytes at birth? So it has come down to 6 lakhs to 8 lakhs. Right? It will be around 6 lakhs to 8 lakhs. So now, during childhood, so most of the oocytes, they become atretic. They get degenerated. So during the childhood, before the puberty, and at puberty, if you see that, only 40,000 cells are there during the puberty. So from the 7 million during puberty, it has come down to 40,000. right? So out of this 40,000 cells, less than 500 will be ovulated. That means every month there will be some 15 to 20 follicles which will start maturating, but only one follicle will become a Graafian follicle and then release the ova, right? So out of 40,000 cells, finally it will come down to around 500 cells which will get ovulated. Okay, right. So this is the difference. So the oogenesis starts before birth. Maybe it's all started with around 7 million cells. Then at puberty it has become around 40,000. Out of this 40,000, only 500 will ovulate. Okay. Now this is the thing which we want to think about. Some oocytes that reach maturity late in life have been dormant in the diplotein stage of the first meiotic division, right? You know that primary oocytes gets arrested in the first meiotic division in the prophase stage. So suppose if it gets ovulated after 40 years, so that cells remain dormant in first meiotic division stage for about 40 plus years, right? So the lifespan of one single cell can be 40 plus years. Okay, so you need to think about that one. So primary follicle, you all know that primordial follicle, there's an oocyte surrounded by the follicular cells. These follicular cells, which are flattened initially, they tend to become cuboidal and then it becomes stratified. Stratified meaning is one single layer will become multiple cell layer, the follicular cell layer. So at this stage, these follicles are called as primary follicle, right? So we were talking about primordial follicle where the oocyte is surrounded by a flattened single layer of follicular cells. So this primordial follicle will become primary follicle. So I'll just show you a picture of primary follicle. Maybe, okay, I'll just show you that one. Okay. Now, what happens during puberty? So during puberty, what happens? For each cycle, each monthly cycle, there will be some 15 to 20 follicles. They tend to develop and tend to get mature. Right? Every month there will be around 15 to 20 follicles. But usually among this 15 to 20 follicles, only one follicle will reaches its maturity. The other follicles will become atretic. Right? So maturity in the sense, the follicles also will undergo stages from primary follicle to secondary follicle to Graafian follicle, and finally which will release the ova. So others will become atretic. Now, when the secondary follicle is mature, so there will be a surge in the luteinizing hormone, which induces a pre-ovulatory growth phase. So now, just before this ovulation, the meiosis 1 gets completed. Right? Just before this meiosis, the meiotic first division gets completed before ovulation. Okay. So all these years or all these months, the cell will remain dormant in the prophase stage of first meiotic division. Okay. Right. So coming to the follicles, the first stage of follicle, it was called as primordial follicle. There will be a single layer of follicular cells surrounding the oocyte. Then the single layer becomes cuboidal and it becomes multiple layer. At this stage it is called as primary follicle. Primordial follicle to primary follicle. And within the primary follicle, only the start accumulating and it will become a follicle called as antral follicle or secondary follicle. Right? So once there is a formation of secondary follicle, it gets further differentiated into a mature follicle called as Graafian follicle. So these are the stages in the follicular development. Follicular development is different from that of the development of the oocyte. Okay, try to differentiate what is a follicle and what is the oocyte. So follicle wise, we call it as primordial follicle, primary follicle, secondary follicle, Graafian follicle. Right? Oocyte wise, we call it as primary oocyte, secondary oocyte. Okay, fine. Now, this antral stage is the longest, whereas the mature vesicular stage encompasses approximately 34 hours before ovulation. Okay, this is not very clinically significant, so you don't have to take it down. Okay, so this is the picture to show you the different stages of follicles. So we'll start with this primordial follicle. So we know that primordial follicle was initially having one single layer of follicular cells. Now if you see this follicle, you will have a multiple layer of cells. So here the primordial follicle gets differentiated into a primary follicle, right? Now as the follicle grows, so slowly there will be an accumulation of fluid here, right? There is an accumulation of a cavity here. So this vesicular follicle is called as a secondary follicle, right? So now there is a larger accumulation of this one, so it is also called as an antral follicle, and some authors describe it as a tertiary follicle. And then finally the matured stage of a follicle is called as a Graafian follicle, where the ova gets released, right? The ova gets released. So these are the various stages in the follicle, from primordial follicle, primary follicle, secondary follicle to a mature stage called as a Graafian follicle. Now, so within this follicle, this is the oocyte. So if you see the stages of oocyte, so the primary oocyte till ovulation, it will get arrested in the first meiotic division. So just before ovulation, the first meiotic division gets completed in case of a primary oocyte. So you can see here, maybe this is the primary oocyte. So it gets arrested in the first meiotic division, where it forms a secondary spermatocyte, secondary oocyte just before ovulation. And this is also gets arrested till fertilization. So unless the fertilization is there, this division is not complete. I'll come to that later. So this is what happening, like primary oocyte gets differentiated into secondary oocyte before ovulation, where there will be a formation of one secondary oocyte and one polar body, right? So this is in difference, in contrast to that of the spermatogenesis. Okay. Now, so the secondary oocyte is the one which gets ovulated. And meiosis 2 completed only if there is a fertilization. If there is no fertilization, the meiosis 2 is not completed in case of oogenesis. Right? So this is a summary of oogenesis. If you see here, there might be division of polar body also. So finally at the end of oogenesis, we might get one oocyte and 3 polar bodies maximum, right? But at the end of this spermatogenesis, we have 4 spermatids from one spermatogonial cells or a spermatocyte, primary spermatocyte. So few take-home messages. Oogenesis starts before birth, number 1, right? The primary oocytes gets arrested in which stage of cell division? Prophase of cell division, right? First meiotic division gets completed just before ovulation, right? Meiotic 2 gets completed only if there is a fertilization. So these are the things you need to remember in case of oogenesis. Okay. These are the same thing. Now, I said like meiotic 2 gets completed only if there is a fertilization. Till that stage, till fertilization, the secondary oocytes get arrested in metaphase stage. So this is a slight difference. Primary oocyte gets arrested in prophase stage. Secondary oocyte gets arrested in metaphase stage. First meiotic divisions gets completed before ovulation. Second meiotic division gets completed only after fertilization, only at the time of fertilization. So these are the things you need to remember in case of oogenesis, right? Okay. So the meiosis 2 is completed only if the oocyte is fertilized. Right? Okay. Now, so things for you to remember, take home message, and then for you to go and read more. Oogenesis starts before birth, spermatogenesis starts at puberty. Right? Oogenesis results in one secondary oocyte. We all agree, right? And rest of the things are called as polar bodies. Okay. Spermatogenesis results in 4 spermatids. The second difference, right? The total time period taken for the process spermatogenesis is approximately 74 days, right? 74 days. These procedures, this duration is quite significant because even after vasectomy, there is a possibility of conception, right? Immediately, if there is a possibility of conception even after vasectomy if this time period is not exhausted. Now, this you need to think over, and then an oocyte can survive for 40 plus years, right? There is one theory called as old egg theory. You'd have heard about Down syndrome, right? So Down syndromes are common when the mother's age is more than 30-35 years, right? So why? Because one reason might be because of the prolonged dormant stage, there is a possibility of chromosomal disjunctions, and there will be a possibility of chromosomal disorders in case of pregnancy that are occurring in late maternal age. Okay. The last one, during oogenesis, the primary oocyte is arrested in prophase 1. So before ovulation, the oogenesis gets completed, that is the first division gets completed. At ovulation, the secondary oocyte is arrested in metaphase 2 and it is completed only if fertilized, right? So this is a take-home message and the summary of this spermatogenesis as well as oogenesis, which you should not forget, right? Fine. Some doubts nobody had? Yeah. Total. Right? So finally it comes down to around 500. Right. No, it's a part of spermatogenesis. Right? Spermatogenesis can be a subdivision of a spermatogenesis. Spermatogenesis refers to the entire process. It's a broader aspect. Okay. Yes. The differentiation between primordial follicle and primary follicle. Primordial follicle, the surrounding follicular cells will be single layer and flattened, right? So once it becomes differentiated into primary follicle, the flattened cells become initially cuboidal, and then slowly the single layer will become multiple layer of cells. It is called as stratified follicular layers, right? So that's a primary. During the secondary stage, slowly within the follicular cells, the fluids start accumulating. So it becomes a secondary follicle or an antral follicle. The accumulation of fluid will become increased, and then the oocyte will push towards one corner of the follicle. So that stage is called as a mature follicle stage, or it is also called as Graafian follicle. Okay, fine. Now, so if time permits, just work it out again, the difference between the mitosis and meiosis, and read from the textbooks the primordial germ cells and try to differentiate oogenesis and spermatogenesis, the difference. Okay, so this for you to read, go back and then read. Read about abnormal gametes that is given in your embryology books, like abnormal sperms, right? Abnormal gametes, and maybe you can just go through some YouTube videos, or you can just Google it to see the sperm motility. So how actually the sperm looks like. So go and then see some videos how the actual real sperm looks like, how it is motile, and also what is a normal sperm count and morphology. Right? So there will be a WHO classification, what should be the normal sperm count and how the sperm should be, how much there should be motility, morphology, as well as now we have one more parameter, that is sperm chromatin. Also they look into that during this artificial reproductive technologies. They look into this sperm chromatin also as one parameter. But just have a look at the normal sperm count, the morphology, as well as how it appears and how the sperm moves, the motility of the sperm. Okay.